Once we become familiar with the Reclassify tool, we can use it, for example, to search for suitable locations. Let's imagine that we seek an area for an agricultural plantation. It needs to be orientated mainly towards the south. Its slope should not exceed 5 degrees, and it should be at an altitude of between 50 and 100 meters above sea level. All this information can be obtained from the digital elevation model, as we have seen previously. Now, it's time to use the Reclassify by Table tool for the elevation, slope, and orientation raster layers according to the conditions already described. We will assign to the orientation between 90 and 270 degrees the value of 1, representing the fulfillment of the condition of being oriented towards the south. To the other values, we assign a 0. In the case of slope, we assign the value 1 to fulfill the conditions of the values being between 0 and 5, and to the rest we assign the value 0. To the elevation layer, we assign the value 1 to the interval between 50 and 100, and all other values will get 0. We modify the symbology of the 3 layers in such a way that the value of 0 is displayed in red and the value 1 in green. Now, with the 3 layers reclassified to the format true, represented by a 1, and false, represented by a 0, we need to perform an algebra operation to find the location where the 3 layers meet the condition. For this, we will use the multiplication operation between the values of the superimposed pixels. In the event that the pixel of one of these layers has a value of 0, that is, one of the conditions is not observed, the result of the multiplication will also be 0. The location does not comply with one or more conditions. The tool for these operations is called the RASTER calculator, and we find it in the RASTER menu. In the list of raster bands, we look for the bands that we want to interact with. Elevation _50 100 first, and then we insert the asterisk as a multiplication operator. Next, aspect _south layer, we insert the multiplication operator, and then we add slope _flat raster layer. We fill in the path where we save the results in GEOT format. We verify the projection and accept. Now, the ideal location layer represents in value 1 the areas that comply with the 3 conditions, and in value 0 those that do not. We assign the same symbology to it and check the accuracy of the result by activating and deactivating the layers.